Hello everybody. Today we are going to talk about the exceptions and about how to handle exceptions, okay? So first, what is an exception? Exception is just a situation that can happen in our program that will stop our program. So it is a bad thing, right? When exceptions occur? Well, look, when I do something like that, for example, can I divide by 0? No. As you can see, this program has been stopped. Here we can only close that program now, and that's all. So everything after it, like that, if you had more instructions here, wouldn't be executed. So you can see the program has stopped working. That's very, very bad. Of course, there are many other situations when something like when our program can stop. For example, we can allocate memory, right, with the new word, and for example, we won't have enough of that memory when we try to use the new word, and then the exception might occur, and then our program will stop working, and other things like that. And we should be able to handle that exceptions. Okay, now I'll try to show you very easy example. Look, I will create a variable, for example a, and I will assign it here a value 5. Then I will show you how to handle exceptions. Look, we can try to do something. That construction is telling us that we should try to do everything between the opening curly bracket and closing curly bracket. Okay. We should try to do it, right? And here I will, for example, multiply a by, for example, 10. So a will be equal to 50 right now. And let's assume that a shouldn't be 50. Let's assume it is an exception that will stop our program. Then I can do something like that. If a equals 50, please throw exception. So throw, for example, that a here. So we threw the object a somewhere. And well, when we threw something, right, we should catch it. Because when we don't catch something like that, our program will stop working. As you can see, it doesn't compile even here. Well, we have to catch it, because otherwise we'll make a big hole in the earth, right? When something is falling, it is making a hole. Okay, so we have to catch it with the word catch. Here, in the between the parentheses, we should say what we want to catch. Right now, we want to catch what? We want to catch something what is integer, right? Because that object here that we are throwing is what? Is integer. So let's call it here, for example, e. And here we can catch that error. So I can say something like that. A cannot be equal to a, for example, like that. And now when I build and run that project, as you can see, that thing has been written to the output. But you might be like, hey, why I just didn't do it that way, right? Here and everything will be okay. But look, now the instructions after, so for example here are other instructions, right? That instructions won't be invoked, as you can see. If I did it that way, the instructions after also got invoked. That's the first thing. The second thing is that that are special things that catch and try constructions, and they can catch errors that cannot be catched by the if instruction, okay? Like, for example, memory allocation. Okay. We are making here an example that is as easy as possible. So, if I change, for example, that guy here now to double, what will happen? As you can see, this application has requested the runtime to terminate it in an unusual way. Please contact the application support team for more information. And our program stopped running. Why? Because we threw here A, which is double, and we could catch only things that were what? Integers. So we threw something into the space and we didn't catch it. It made a hole in our program, right? We have to catch everything always. So we can do it that way. We can make another catch instruction, for example, that will be for integer and that will be for the double, like that. Now everything will work fine. Or, and of course everything after the catch is working, la 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 la, as you can see. That's why catch is cool. And or you can do it that way. We can just catch everything possible. So now here I can write something like this is going to be just leave it like that. As you can see, this is going to be this is a message that will be shown when other catches, so other things like that, other catch, maybe other catch instructions won't be invoked. So this is like else statement in the if instruction, right? And now we can catch everything here easily. When it's double, when it's a character, right? We can do it easy. Okay. Now, I would like to tell you about the true use of something like that. Look, we can make a function that we'll call division. As the first parameter, we'll take the number that we'll divide. As a second number, we'll take a number that will divide the number A, right? And now we can just return the A divided by B. And here I will just run division of, for example, 5, 0. So I want to divide 5 by 0. And let's assign somewhere the result of that. And the result is here we'll send result. Now when I build and run, A cannot be equal to something. Build and run. As you can see, the result is infinitive. Well, our program somehow managed to divide 5 by 0, but it's because there are double types, and if somebody divide 5 by 0, then the result is like that. But we shouldn't allow a situation like that, right? So how to manage something like that? We should check here if B is equal to 0 before, and if it is equal to 0, we should throw, for example, B. So this catch instruction will be invoked now, right? As you can see, this instruction got invoked. So we could say here error, la 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 la, and other things like that. And this instruction didn't get invoked, right? So after the error, everything to the closing curly bracket here wasn't invoked. So it's cool. But it should be written a bit more professional way. We should create now here a class that we'll call that should be self-descriptive, and we call it division by a zero exception. Okay, we just created the class in the same file. Well, we won't. I don't want to create other files, so it won't take our time right now. And in the public section, we'll create a function that will get the error message, and we will just make it inline function. Do not divide by 0. Error. Something like that. And now we can throw here object like that. We can do it that way, or we can just do it that way. The second version is better because, well, when the error won't occur, so when b is not equal to 0, we don't need to create division by 0 exception, right? So this is better version. And it means now that we have that type of error thrown somewhere here if b is 0, right? So we can catch it. We can do it, for example, well, when I build and run that program, this catch got invoked, right? But we can, for example, specify it, so division by 0 exception here. And now, because E is really that object now, right? So it means that we can get to the get error message, and we can do something like E and then get error message. Build and run that program. As you can see, error, do not divide by 0, please. It works fine. And this is the professional way, and that should be done that way. And we also should inform other programmers about what is being thrown in our function. So here we are saying, hey, remember that somewhere here in our function there might be thrown that error. So you should remember about that you should catch it. Because if you do not catch that thing, it will cause problems, right? Because you see, now we can do it, for example, like that. I'm not catching it now. And our program has been terminated, right? It stopped working. So imagine that our function is like 100 lines long, and it's hard to notice where is something thrown. If I do something like that, I am saying, hey, remember, there is something like that, and you see, for example, the programmer can click on something like that, and he will notice where something is being thrown, and he will know that he has to catch that error later. So this is used like that. And you can also leave that thing empty. When you leave it empty, it means that there is there is nothing thrown in that function, right? And you are informing, you don't need to worry, you don't need to use the try catch statement. So this is like that thing here is used as an information, okay? That examples are really easy. Normally the things are used a bit in different places, like in the memory allocation, but we'll talk it probably in other courses when we write harder programs, right? Right now it will be just loss of time. Okay, that's all in that lesson. Thank you very much.